The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for our next webinar related to our Municipal Concrete Paving webinar series. Now, in previous webinars, we looked at the benefits, design, and construction of concrete pavements in Ontario, and today we want to put it all together by showcasing a case study from the Region of Durham. The webinar today will focus on the municipality's viewpoint and the process that was taken to choose concrete over asphalt. Now, the project we will look at is Harwood and Bailey, the intersection reconstruction pilot project in Ajax, which was a major step forward for the region to explore the benefits of concrete. And we are quite excited to have Ben McWade from the region today to provide an overview of the project. Now, before we get to Ben, just do some housekeeping items. My name is Alan Carey, and I'm the Director of Technical Services at Concrete Ontario, and I will be your facilitator today. In addition to myself, we also have Tim Smith. We welcome Tim back. Tim previously presented the first two webinars for us, and him and I will be tag teaming the facilitator duties today, along with Ben, the presenter. In terms of housekeeping,
hi everybody.
Good morning, Tim. In terms of housekeeping, approximately will be a 45-minute webinar with questions and answers at the end. All participants are muted. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your question. All questions will be addressed at the end of the webinar. The webinar is currently being recorded and will be posted on the Concrete Ontario website, along with a PDF copy of the presentation. And the follow-up email will be sent to all attendees with the link to the recording and the PDF presentation. Now, if you did miss webinars 1 and 2, where we talked about the benefits, we talked about a little bit of design, the construction side of concrete pavements, again, no worries. It is posted already on the Concrete Ontario website, the same link that we will be sending to everyone today. So you can check it out and review the information. And you can also forward it to any colleagues that may be interested in learning more about concrete pavements in Ontario. Now let's get right into it. Your presenter today is Ben McWade. Now Ben is a project manager with the construction management group at the Regional Municipality of Durham and is the CCIL approved supervising engineer for the region's materials testing lab. He manages capital construction projects throughout the region, including roads, bridges, sewers, and water mains. Now prior to this role, Ben was a project manager with the region's transportation design group, where he managed road and pavement design projects. Ben has worked at Geotechnical and municipal design consultant firms prior to coming to the Region of Durham, and he has experience designing and administrating road, sewer, and water main construction contracts and managing materials testing programs, including granular, concrete, and asphalt testing and inspections. Now, when it comes to this project, Ben had a very integral role ensuring that the reconstruction of Harwood and Bailey would consist of concrete, and there's no better person to talk about this project than Ben. Ben has presented this presentation numerous times at different conferences around the country, actually. So it's going to be great to get an update from Ben about what's happening in the Region of Durham and how the pavement is performing. So good morning, Ben. Thank you very much for helping us out today. How are you?
Good, thanks, Alan. I appreciate you having me here. I'm really excited to share this presentation to some new people and just provide my insight from the municipality view.
Yes, we're really looking forward to it. It is very exciting again for the region because this was a major pilot project. So I'll turn over the keyboard controls to you right now, and you can kick off the presentation for us.
Perfect. Okay, so I'd like to give you some background on why we decided to do a concrete pilot project and how we picked this location. And then I'm going to go through the planning and design process for this project, as well as the construction, talk about staging and some other considerations. My plan is to really give you an insight from a municipality's point of view about the planning and construction of a concrete intersection or similar concrete pavement, should you be considering something like this for your municipality. Okay, good. So for those of you that aren't aware, I'll give you a quick background on Durham Region. We're an upper tier regional municipality just east of Toronto. Durham consists of 7 lower tier municipalities spread out over a really large area, about 2,600 square kilometers. We have a mixture of rural and urban centers, and our population is growing to be around 1 million people by 2031. I think right now it's around 700,000. So as that population grows, so too does traffic, obviously. So we need to prepare for that growth now in today's pavement designs. We have a range of road types, from like a rural 2-lane highway to multi-lane urban arterial roads with over 30,000 vehicles a day. So there's really no one-size-fits-all solution to pavement design, and I think that should be considered whenever you're doing your pavements, whether they're asphalt or concrete. So one of the things that I'd just like to mention as municipal engineers is that sometimes we focus a lot on the cost and the schedule of a project, and not always consider new things and whether or not that design is suitable. So the focus is sometimes on, how much is this going to cost to build, and we needed this yesterday, so when can we get it done, especially when it comes to road rehabilitation. We use established pavement designs that we're used to using and we're used to administering and we're comfortable with. But when all is said and done and the job is finished on time, hopefully, and on schedule or on budget, hopefully, do we actually end up with the right final product, and does it last as long as we hoped that it would? And are we constantly assessing that? So one of the things that we've come across in our region is rutting at major arterial intersections. We've had some poor asphalt in the past. This is the Harwood and Bailey intersection that I'm going to talk about today, but these pictures are common issues that we see throughout major intersections where we have trucks and loaded buses passing through. So in 2015, we decided to explore an alternative pavement design, just as a trial, something that would stand up better to heavy trucks and buses that we see as the population and traffic grow. So our motivation was really stemming from, well, partly we wanted to introduce some competition to the asphalt industry because we've only ever used asphalt in Durham, and we thought we could maybe bring some prices down if we started using other material types. And then the second was just finding a more robust pavement that would last longer and we wouldn't have to come back as frequently to repair or rehabilitate it. So we put forth the idea of a rigid pavement pilot project to address the rutting, and we selected this intersection in Ajax, Harwood Avenue and Bailey Street. This site, so this was in 2015, 2016 that we were talking about this. The intersection was last reconstructed in 1999 when these slotted left turn lanes here, you can see, were built. So that pavement design in 1999 consisted of 40 millimeters of HL1 asphalt, over 100 millimeters of HL8, over 150 millimeters of new granular A base, and 600 millimeters of granular B subbase. And there was early rutting and shoving identified within 1 to 2 years. So by 2001, those pictures that I showed you back here, that was pretty much what it looked like within a couple of years after construction. So this intersection, just to sort of orient you here, is located in the heart of Ajax. It's very urban. Ajax has a population of about 120,000 people. So Bailey Street is that east-west road. It's a 5-lane road, and Harwood Avenue is the north-south 5-lane road. Both of these roads see about 20,000 vehicles a day and 5% trucks. There's a church at the southeast corner and a school right next to it. There's a big apartment building, the northeast corner. And at the southwest, you can see it's under construction in this photo, but there's a large development happening of commercial and residential and entertainment complex down there. So we kind of wanted to get in and get out and not come back every 5 years or 10 years to rehabilitate this. And we thought, you know, if concrete works, that's great because we can get in and build it and leave it alone. Okay, so the design of this project was done completely in-house. I was the design engineer on it, and we have our own CAD staff, and we put this all together in-house. The first thing we did was we considered a few different pavement options and considered things like schedule and cost. We retained Golder to do a geotechnical investigation and provide some input on the pavement design. And then we put together a comprehensive outline memo, and we circulated it internally and to the Town of Ajax as well, just sort of outlining the problem and what our plan was for a pilot project. We did a life cycle cost analysis, which I'll talk about a bit more later. And this list of concerns is what we got back. So I didn't have any experience with concrete pavement design. When we started this, I learned a lot going through it, and really the region as a whole didn't. I mean, we had a few concrete pavements that we had inherited from before the region existed, but we never designed any. And so these were some of the questions that came back from our internal groups. Like the cost was a big one. Everyone sort of knows that concrete costs more, so they wanted more information on that. Friction was brought forth. Is it going to have enough friction compared to like an HL18 asphalt? Is it going to be noisier? Vehicles driving through there, are we going to get complaints from the adjacent apartment buildings? The color was flagged by a few stakeholders as well, just because it's different. And so when a driver comes across it from the black asphalt, you know, there was concerns that maybe that would be an issue. And then tied to the color is the paint visibility, because all our, you know, our crosswalks and our stop bars are white. So white on gray could be a problem. So that we had to consider during design. As well as maintenance, our depots didn't really know how to maintain a concrete pavement. There's worries about it cracking. Utility cut restoration was another big one, especially with this development at the southwest corner. Utilities coming and cutting in new crossings, and how would that affect the pavement in the long run? Traffic detection loops was another one, which I'll talk about later, and construction staging. We did produce a life cycle cost analysis, and the other thing we did was we did a lot of research. So we spoke with the Cement Association and with Concrete Ontario, and they were both very, very heavily involved in the planning and construction of this project. We spoke to people at MTO and the City of Toronto, and the City of Windsor, which have a lot of experience, more experience than we do with concrete pavements and composite pavements. And then some of the DOTs in the US, as well as the University of Waterloo. They were actually involved in this project. They wanted to do a bit of a traffic study, which was sort of separate. They wanted to see how our staging would affect traffic flows. So they were involved in that capacity. Okay, so the life cycle cost analysis, there's this document that I believe is available if you search it online. It might even be on the Concrete Ontario website, but it's available, it's out there, and it's by the ARA, and it's called the Methodology for the Development of Equivalent Pavement Structural Design Matrix for Municipal Roadways. And it talks about how you can do a life cycle cost analysis, and it's sort of the MTO approach. So we went through, this is an excerpt from that document, and it gives you a sort of an idea of how to do this. It's not a complicated exercise, but it does require a lot of assumptions. So you can see here on the left, there's an estimated maintenance and rehabilitation schedule. So in 5 years, you're going to route and seal the asphalt. You know, in 35 years, you're going to mill the asphalt. And this is sort of based on, you have to adjust this for your municipality based on your past experiences with asphalt. and then it's converted to a net present worth, and at the end you get a total cost for your maintenance and rehab over the analysis period. So that might be 40 or 50 years. And then you do the same for concrete, and then that way you're comparing the total life cycle cost of the asset instead of just the construction cost, because the construction cost is easy to say that, well, asphalt's cheaper than concrete, but if you look at the total life cycle cost over 40 or 50 years, it might work out. It usually works out that concrete is cheaper, but it's an exercise to go through, and it's just one piece of. Okay, so I'll talk a bit about our detailed design. Like I said, we had geotechnical investigation completed, and we discovered that Harwood Avenue had about 175 millimeters of asphalt over 320 millimeters sand and gravel, and Bailey Street was 165 millimeters of asphalt over 405 millimeters of sand and gravel, and then it had a sand subbase. So there was a bit more of a structure on Bailey Street than there was on Harwood, but neither one of these existing road makeups met our arterial road design. So if we were going to do an asphalt reconstruction, it would be full depth asphalt and granular. So that would include 600 millimeters of granular B, 150 millimeters of granular A, and then all new asphalt. So that's what we were comparing in our life cycle cost analysis. We had Golder run a concrete pavement design as part of their assignment, and this is the design that we came up with. Again, we had input from Cement Association and Concrete Ontario on this, and this is what we settled on, was 200 millimeters of 32 C2 concrete, plain concrete pavement, which means there's no reinforcement in it. That's placed over 100 millimeters of new granular A, which was placed on the existing granular base. So basically we excavated 300 millimeters of asphalt and granular, then compacted the base and placed our new granular A in concrete. Our design does include dowels and tie bars, which I'll talk more about later, and those span the joint. So the tie bars span the longitudinal joints, and it basically holds your lanes together. They're deformed rebar, essentially. And then the smooth dowels go across the transverse joints, which prevent vertical faulting and help with the load transfer from one slab to the next. So perhaps the biggest difference between an asphalt pavement design and a concrete pavement design is that concrete has to have these saw cut joints. So we included a joint layout drawing as part of the design package, which laid out the location for every single contraction joint and isolation joint for the whole intersection. Sometimes this step isn't done in the design, and it's left up to the contractor to decide based on guidance from the OPSDs for concrete paving, but we figured it would be helpful due to the complex nature of this intersection with these splitter islands. Here, this is like a southbound left turn, and these are hard islands in between. So to spread out these joints in the field, leaving it up to the contractor, we thought it was not a good idea. The contractor actually followed this plan to a T, so they were really thankful that we provided it, and it was, it was provided up front and allowed to see that during tendering, and then they had it on site and they followed it, so it was worth the effort. There's a lot that you have to consider when you do your joint layout, because you want the panels to be relatively square, and if you don't lay it out properly, then you're going to end up with weird sort of triangles and long rectangles that are just going to be cracking. So we had guidance from that. The ACPA has some good documents about joint layout. This is just a schematic of what I was talking about earlier. So we have smooth dowels that cross the transverse joints, and then we have deformed tie bars crossing the longitudinal joints, and they serve different purposes. So those longitudinal bars are supposed to tie the concrete slabs together, whereas the smooth dowels allow the concrete to move, just not vertically, because we don't want the faulting to happen when the load sort of moves across from one slab to the next. So this is a picture in the field of these dowel bars, which are in these baskets. And those are so that's the load transfer device. And then we have the deformed tie bars along the longitudinal joints. Okay, so some other considerations during detailed design of concrete pavement that we had to focus on was that really the important thing for concrete is that it has a stable, uniform, granular base. So that granular base doesn't provide a lot of strength, whereas in asphalt design, you're really relying on your granular A base for strength to provide a continuous support. So you want to make sure that your granular base is consistent. You don't have pockets of soft soils or something. The joint layout is critical, which I've already discussed. Dowels and tie bars, as I've mentioned before, that was new to us, being new to concrete pavement. A concrete asphalt joint transition. So at the limits of our concrete pavement, where it abuts up to the existing asphalt, we had to design that properly to make sure that there was a good transition. So it can't just have like a butt joint, otherwise you're going to end up with vertical movement and faulting. So what we ended up doing here actually was, and there's a detail for this, I think we got this from the ACPA, but you basically build a sleeper slab of this concrete. So the concrete sort of tapers down and then the asphalt paves over top of it and provides support, and it's kind of a smooth transition for the loads moving from the asphalt to the concrete and vice versa. Pavement markings, I mentioned there was some concern about the white on gray. What we decided to do was have a black backing to provide more contrast. So this is what it looks like as a finished product. So for the crosswalks, we wanted them to be higher visibility, and there's skip lines through the intersection for turning vehicles. I believe those have a black backing as well. So it's just a thicker black mark below the white normal crosswalk line. The other thing that was new to us for pavement markings was that we usually use thermoplastic or field reacted polymeric pavement markings. And thermoplastic really, it relies on the thermal bond between the paint and the pavement surface, which works well for asphalt, but not so well on concrete. It's a bit more porous and it doesn't get that bond. So MTO actually recommends that you don't use thermoplastic on concrete pavements. So we used methyl methacrylate, which is a type of field reacted polymeric material, and it is listed on the MTO designated sources list. So it is an approved product, and you have to make sure that and we specified in our contract that the concrete surface was, mechanically cleaned and that it didn't have any of that concrete dust on it, and that there was some exposed aggregate so that the paint would really bond to that, to the concrete. And then traffic loops was another consideration. We didn't want that to be cut in to the new concrete, so we ended up using preformed loops that was set right on the granular. Construction staging. The concern about concrete curing time. So we actually close this intersection half of the time. And I'll show you a picture here. So we pushed traffic to the north and had one lane in each direction, and that south half of the intersection was closed. And then we were able to build that concrete pavement. There was a new water main replacement included in this contract as well. So we did the water main first, and then did that concrete pavement on the south side, and then we flipped this. So we pushed traffic to the south and worked on the north half of the intersection. So it was closed half at a time. We discussed doing this in quadrants to avoid the partial closure, but it was just, especially with these islands, it was just too finicky and there wasn't enough room for the contractor to work, so we ended up designing it this way. Okay, I'll get into a bit more of how this was actually built and show you a lot of pictures from construction. Oh, sorry. So here's just a real life view of that closure. So this leg on the right side of your screen here, that's the south leg of the intersection. So that's Harwood Avenue. And you can see all the traffic is pushed to the north. So in this picture, the south half of the project is pretty much paved and done. They have to still do one of the eastbound lanes, and then they would flip traffic and do the north side. This is the equipment that they used. The contractor used a vibratory roller screed. There's a few different types of equipment they can use. Often the slip form paver is preferred, but that's for like stretches of highway where you're just going, for kilometers of paving and it looks like a giant asphalt spreader. They couldn't really use something like that here because going around the radii and the islands, it just wasn't practical. So this equipment is a bit more mobile and more agile around the curbs and the islands. So you can see they've got all their dowel baskets laid out and they're just placing the concrete right over top and paving it with this roller screed. So this, I think, is the south half of the intersection, and they did have a pumper truck in there to reach certain areas that they couldn't just dump. This was constructed in August and September of 2017. So it was hot on some days, but you'll see some of these photos where the guys are actually bundled up a bit. So it wasn't the hottest summer that we had that year, but we did have to consider curing compound to be placed right away, which I'll talk more about later as well. Here's some pictures of the tining. We had originally specified longitudinal tining because we were concerned about the noise of transverse tining, but we discussed this with the contractor, and when you're doing an intersection, you're going to end up with vehicles passing in both directions over the tining anyway. So we agreed to let them do this transverse tining, as you can see here, instead of having to drag tining behind the paving operation. But I mean, we didn't do a noise study before and after, but we haven't had any complaints, and I don't notice anything personally when I'm out there or driving over it. It's such a short section, you're over it in a few seconds when you have a green light, and when you stop at a red light, you're driving slowly, right? So we don't have that same that same humming that you get when you're driving on the 407 or on a concrete paved highway. But you can see it is a pretty aggressive texture that we ended up with after tining, and so the concerns about not having enough friction, we learned after the fact was not a concern at all, because there's a lot of friction out there. So as I mentioned, the curing compound was placed right away as soon as the water sheen was gone from the surface of the concrete. Then they sprayed it with curing compound, and that was a critical step, especially in the heat. We had people from the Cement Association and from Concrete Ontario. They were on site most of the time throughout construction, sort of providing guidance to the contractor and documenting themselves. We also had our staff on site. So there's another section of how they staged. You can see they used these formworks, and they did one lane at a time. And then once the lane was cured, then they used it as the formwork for the adjacent lane. We replaced some curbs as part of this project as well, just because the curb was old and needed to be replaced. Maintenance holes, catch basins, and other structures on the road. required box outs. So this is part of our joint layout plan, just to prevent cracking. So the box out includes a perimeter isolation joint, so that maintenance hole lid and frame can move independently of the surrounding pavement. So there's a picture of one being built here. So the traffic loops, again, we wanted preformed loops so that they weren't cut into our brand new concrete. There was some concern that because the loops were sitting on and around the dowel bars, the load transfer devices here, there was concern that the steel would continually trigger the loop, like the left turn signal, for example. But this isn't the case because the loops are calibrated after installation and they're triggered by the net change in the electromagnetic field when a vehicle passes over top. So as long as they're calibrated with all that steel sitting around them, then that steel won't impact or have an effect on it won't trigger the loop, because it's really just the change in the electromagnetic field when a vehicle is stopped on top. So it wasn't an issue. We did specify a continuous rubber hose type loop, which was an NTOD, and we ended up going with prefabricated PVC because they couldn't get the rubber hose, but we haven't had any issues with it. It's also an MTOD, so it was also an approved method. Saw cutting was typically done within the first 2 hours of curing. As soon as they could get on with the early entry saws, then they were on their saw cutting. This is a photo of a curb that was maybe saw cut a bit late. So you can see on the left there's a crack has formed next to the saw cut. So we had them actually cut that out. So you can see on the right, they had a saw cut on each side of that and pour a new piece of curb. That was the only saw cutting issue we had on the whole project. We haven't had there was no cracking where there shouldn't be outside of this. We also specified MIT Scan 2, which was used to verify the position alignment of the dowel bars. We had them do it on every 10th joint, make sure that the dowel bars were where they were supposed to be, and that the alignment of the dowel bar and the depth was proper. So that dowel bar should be about mid-depth slab. So we specified this, and it was fine. It was probably didn't really need to have them do this. This is more for if you're doing highway construction, and we could pretty much inspect all the dowel baskets and watch it get paved and know that it was in the right place. So I want to show you some photos that are a bit more recent, just to show you how it's held up over time. This photo was taken, I think, a year after construction. If you look at the crosswalk line, right at the nose of the island and a bit closer, you can see there's parts of it that are missing. That was because the methyl methacrylate is a bit thicker, and also we did the 2 layers of it with the black backing. So the snowplow caught it a bit in some areas and chipped it off. So that's probably a bit worse now. Every winter it might get a bit worse. I'm not sure, but it's something that's going to have to be maintained. And we thought about this during detailed design, but there wasn't really any way around it unless we wanted to grind out the length of the paint line and have the paint recessed into it. I know that's been done. I spoke with somebody in the west end of the GTA, I can't remember what municipality, and they did that method for concrete roundabouts. And all the paint lines, they actually ground out a few millimeters and placed the paint in that grinding. So maybe we could have done that and it would have helped this, but it seemed like a big undertaking. Here's a picture of one of our buses stopped at a bus stop within the limits of the concrete paving. You can see here we designed the concrete to extend beyond where the bus stops. And we did that because we wanted the bus to be fully on the concrete and not bridging over the joint. So this asphalt to concrete transition is, I showed you that detail before, where the concrete actually extends a couple meters under the, it continues beyond where you see the asphalt starting. But we didn't want the starting and stopping forces to bridge across that transition. And this puts all the forces directly on the concrete, which is, I think, better in the long run. Here's another picture. You can see these crosswalk lines are fine on this side of the intersection. There's no cracking. All our joints look clean. Again, this was a couple years after. So here's probably the biggest issue, and this is kind of, this is something that in hindsight we should probably have done differently. So here's a maintenance hole that was actually, this is a storm maintenance hole, and it was buried under the existing asphalt. So we didn't know it was there. We actually thought it was in the island, as according to our as-builts from previous years. But when they peeled off the asphalt to do this project, they found this old storm maintenance hole. So we raised it to grade because we figured that was the right thing to do. And then they built a isolation joint around it, and we paved it just like any other manhole. But the unfortunate part about this one is that it's actually directly in the wheel path, and right where vehicles are stopping. You can see the stop bar here. This is for eastbound traffic on Bailey Street. So over time, vehicles would stop and start, and they're right on this maintenance hole. And this is what the maintenance hole looks like today. It just got pounded by traffic, and it's right at an isolation joint as well. This isolation joint along the side of it. So this has broken up over time. This has now been, I guess, 3 years or so. So what we're going to do is we're going to go in. We spoke to the depot about ways that we can fix this, and they actually don't need that maintenance hole. So we're going to go in and we're going to pull up the area around the maintenance hole and the slab adjacent to it, because it now has a crack that's transferred through it. We're going to lower that maintenance hole back down to subgrade and then rebuild our granulars and concrete on top of that. So that's what we're looking at doing now, either this year or next. So that's pretty much the overview of our project. There is a YouTube video here that I just want to share the link with you if you want to take a screenshot or something, or maybe we can post this on the website. But it's a video of the construction happening, and it's a time-lapse video. So we had a camera mounted on one of our traffic signal poles, and it recorded pretty much the entire project. So you can see how it was staged and how the concrete was poured, and it's kind of interesting to watch.
That's great, Ben. Thank you very much.
Sorry,
oh, go ahead. Yep.
Okay. No, I just had one more thing. I just wanted to talk about maturity testing quickly.
Sure.
So we did specify maturity testing, which is, actually monitoring the concrete in place, and it was helpful, and it's something that I would do again. I think if we did another concrete pavement, because it tells you exactly when you've reached your minimum strength to open up to traffic, and that's important if, especially in this case where we closed half of the intersection, so we could minimize the duration of that closure.
And how long did it take approximately for the concrete to gain the necessary 20 MPa?
It took about 48 hours.
Okay.
We thought it would be a bit quicker, and typically it is a bit quicker than that, but we had the concrete actually on this specific project, for some reason, it didn't cure as quickly as we thought. It did reach its ultimate strength, but it just took a little bit longer to get there than it typically does.
So it's nowhere near the assumed, 28-day strength gain that it's a huge misconception within the industry.
Yeah, absolutely. Like within 2 days, we had it open to traffic.
Perfect. So we do have some additional questions. We will share this presentation with everybody. It will be on our website so people can access this YouTube link and they can see the full time lapse of the reconstruction. So just looking at some of the questions, again, great overview, Ben. Thank you for that. You mentioned that noise and friction ended up not really being a problem. What about the color? Did you hear anything from residents about the color change?
No, it turns out that municipal engineers and people in the industry care a lot more about the color of a road than everyone else driving on it. It's one of those things where you'll be driving and you'll see something that, I don't know, I see things all the time and I point them out to my wife and she has no idea what I'm talking about. But most people didn't notice any difference. They don't care. Like, I think the white paint on the gray is a significant concern because that's a visibility thing, especially in the night or in rainy weather. But so the black backing did help that, but most people that drive through this intersection don't know they're driving on concrete.
Okay. And what was the general feedback from residents? Have you heard anything from them?
Not since it's been built. I mean, we had this was a high pedestrian intersection. There's 2 schools nearby, and we had to accommodate that during construction. So we did have to make some changes to how we got pedestrians through the work zone. And then we did close one leg of the intersection at a time, like the south leg and the north leg. So there were some concerns from residents about that, but in terms of the actual concrete pavement, we didn't hear anything from them.
Okay. I do see some hands up in the chat. So if you do have a question, make sure you are typing in your question into the GoToWebinar questions pane. We are addressing all the questions right now, and there's numerous ones here. The next question is, what municipalities tend to be resistant to change, as I'm sure you're quite aware of, continuing to do shave-in paves and things like that. But what advice would you give to other municipalities that want to explore more of a long-term solution, such as concrete pavements?
I would say similar to what our approach was, get everybody involved in the planning stage. Try and anticipate what their concerns are and put together a comprehensive project outline and try and address everything and ask for input and maybe hold a meeting with different departments, different stakeholders. Like we had our traffic group involved, our construction group. I was in the design group at the time. The depot, they're the ones that have to maintain it forever, so they need to have buy-in. And it's just hearing everyone out and what is the concern and how can we address it? And is it a showstopper or is it something that we can work around? And I think the biggest selling point is the cost. Well, there's 2 things. One is the life cycle cost being much lower, and the other is just the disruption, constant disruption every 5 to 10 years going in there and repairing the asphalt. If you can get in there, and if this, like, we're not planning to go in for a long time before we have to go in and maybe retexture or do a spot repair or something. So if this is the case, if this way it's going to go with concrete and it actually works, then that's a huge selling point to not just the region but also to the residents not having to deal with that.
For sure, nobody likes to see something being rebuilt 2-3 times and sit in that traffic. Now, you obviously did a lot of research when it came to using concrete. You reached out to a whole bunch of different associations and DOTs. But on your end, what reservations did you have for using concrete initially?
Well, I was really spearheading this, and I was trying to get buy-in from everybody. So I thought it was a good idea, and I knew it was a good thing to try, and that was my biggest thing, was let's just try it, and see if it works. And if it doesn't work, then at least we said we tried.
Yeah.
I didn't know anything about concrete pavement design, and I wanted to do it in-house because I didn't know any consultants that really knew anything more about it. And coming from the consultant world, I just knew in the GTA, or at least in the East GTA, we don't have experience with it. So we did it in-house, and we involved Golder, which was very helpful. And like I said, the Cement Association of Concrete Ontario provided a ton of support and guidance. And there is a lot of information out there and a lot of resources. It's just not in this part of the world, or this part of Ontario. So it's just a matter of doing the research, and it's really not rocket science at the end of the day. You just want to make sure that everything's done properly, because it can go wrong if it's not designed properly and if it's not built properly. The other thing I should mention for anyone considering it is, the idea, the whole reason it works is that you want to build it there and have it stay there for like 40 or 50 years. So don't pick a location that's going to be widened in a few years, or that you're going to have a new sanitary forest main to build in a few years, or where there's development and growth happening. Part of the reason we replaced the local water main under here is because it was getting old, but it wasn't slotted to be replaced. But we ended up doing it early because we didn't want to come back in 5 or 10 years and replace the water main under a brand new concrete intersection. So I'd also reached out to all of the utility companies during the detailed design phase and asked for their sort of long-term plans, because we didn't want to find out later that Enbridge had to come and build a new large diameter gas main through the intersection or something, right? So we would have actually, we considered putting in empty ducts and stuff through this intersection for future utilities, but we ended up not having to do that because there were no imminent plans. So hopefully it stays that way, and if there are utility cuts, then we'll have to deal with that.
Yeah, forward thinking is definitely very important when it comes to concrete pavements, because again, you are building it to last. It's not a quick, for example, shave and pave. The next question is, you talked about the life cycle cost analysis, which is very important, comparing initial and final and life cycle cost of the concrete versus asphalt. Just in general terms, what kind of cost did you see asphalt versus concrete for this particular intersection?
So in this case, because our asphalt option was full depth granular reconstruction, it ended up being very close. The construction costs were very close. Usually concrete costs more because it's just the nature of the product. But in this case, if we had gone with asphalt, we would have had to do, full depth granular B, granular A, and then 6 inches of asphalt. With the concrete approach, we could leave all that existing granular and native material and just do new. I think we did 100 millimeters of granular A, and then the 200 millimeters of concrete. So it was a bit more expensive, but like the life cycle cost, it was considerably cheaper. Like it didn't take long. I think when I look at the life cycle cost, it was within the first repair, we were then back to even.
Okay. Just a question about the granular base. Would you have any tips on how to achieve balance between the granular base stability and drainage?
Yeah, like we designed it with a granular array. The underlying soils were pretty well draining. There was some existing granular B in about half the intersection, and then the other half of the intersection had, a material that was close to a granular B. It was like a gravelly sand. So the drainage wasn't an issue, and we put in all new subdrain as part of this project as well. So I think granular A would work. It depends on what you have below the A. And as long as it's free draining, then then that should be good.
Okay. Question about winter maintenance. There's always a question about the light color affecting how much salt is needed because you don't see the contrast of actually how much you're putting on. It is assumed that concrete road always needs more salt. Have you noticed any difference?
No, I haven't heard anything from our depot that they do anything differently. They don't sand the roads. It's just salt and the brining or whatever they do, de-icing. But they just treat this intersection the same with the way they treat the rest of Bailey and Harwood. So Harwood Avenue is actually a Town of Ajax road. Bailey Street is a regional road. But I haven't heard anything from the depots in terms of anything they've noticed, and we haven't had, increased accidents or anything like that. The friction is very good here, and that transverse tining does provide a good macro texture for the water to drain away. So no, there's been no difference in winter maintenance.
Okay, that's great. Another question, was there any concerns in spring, winter seasons when there's heavy rainfall? I guess it relates to the drainage.
Yeah, we had no concerns. We designed this the same way we would an asphalt intersection. We had a pavement elevation drawing that showed all the grades and made sure that everything drained to nearby catch basins. I've been out there in heavy rain, and there's a little bit of ponding in gutters that we didn't replace, but nothing significant, nothing anything more than you'd see at any one of our other asphalt intersections. So everything still drains to the catch basins.
Okay, great. There's one question here that I can just answer. It says, usually what percentage of the 28-day concrete strength is required before you open to traffic? So the MTO requirement is 20 MPa in Ontario. So you need 20 MPa before you're allowed to put traffic on. And you mentioned, Ben, you pretty much got that within 48 hours, which again, strength gain didn't really seem to be a problem in your project.
Right. The biggest thing was because of our complex intersection with the islands, it had to be piecemealed. So, we had half the intersection closed, and they built one lane and then moved on to the next lane and moved on to the next lane. And, so it's really all those previous pours were not critical. They could have taken, a week to cure, and it wouldn't have mattered because we still couldn't open the intersection until it was done. Also, that water main had to get built, so that had to be done first, which was, didn't affect the timing of the concrete. So it was really just the last slab was poured. When it set up in 2 days, then the whole thing could be open. So yeah, it was far from the 28-day, that's for sure.
Yeah, you guys did have that luxury of closing the whole south side, so you didn't really have to flip traffic. But if you had to do that, sounds like the concrete would have performed in a couple of days anyways, and you could have flipped traffic easily.
Yeah, and I mean, if we had done asphalt, we would have been in the same situation because we had to dig out all that granular, right? So we would have had to probably have the same staging.
Okay. There was a question about that broken manhole. What was the reason? I know you already explained a little bit, but can you just summarize again why that manhole cracked the way it did?
Yeah, we think it's because the vehicles are starting and stopping. It's right in the wheel path. So, when you get a big truck or a bus driving over that, and we have enough of them through this intersection, just pounding on that lid, it's broken up all the concrete around it. Thankfully, we had that isolation joint. So you can see in that one photo, the cracks were limited to that area directly around the manhole. And then now just recently over time, there's been a crack that's propagated into the next slab. So, in hindsight, like we didn't know the maintenance hole was there and we thought, oh, we'll raise it and didn't think about the fact that it's in the wheel path. But I wouldn't recommend putting maintenance holes in wheel paths. If this had been asphalt, that would have gotten pounded as well, but you wouldn't have had all the cracking and it would have been easier to repair. In this case, we thought about fixing it by leaving it in place and sort of doweling it all together. But I think we're just kind of fighting the traffic loads. And if we don't need that maintenance hole, it was buried for 15 years and no one knew it was buried. So we're gonna put it back down.
It's always amazing what you find when you actually start digging up, the granular base and the asphalt. I worked on a project where they thought it was going to be about 10 inches of asphalt that they had to remove. It ended up being 17 inches, and they had to actually bring in granular base to fix it and regrade it. So, challenges like that I think are always going to occur, especially with older infrastructure. One more question. Were you able to keep the existing concrete curb? I know you mentioned this briefly already.
In some areas we were. We did do that. In other areas we didn't. So on that joint layout drawing, we showed the location of all the dowels and tie bars. And in some areas we wanted to dowel, we wanted to tie the concrete pavement into the curb to provide more support along the edge. So in that case, in those instances, we had to replace the curb in order to get, just to do it properly. I mean, the curb was old anyway. And we wanted to also make sure that we had good subdrain under there. So we ended up replacing majority of the curb just to sort of do it properly.
Okay. That's pretty much all the questions I have. Tim, did you have anything to add in here as well?
No, only in that one of the key things in the manhole would be if it's right in the wheel path, there would be an edge load because you have an issue of no pavement to transfer that load. So that would be the edge load, and then the pounding of hitting that and going on and off it on a continuous basis would have helped break up the concrete around it. But thank goodness, as it was noted, there was an isolation joint, so it couldn't propagate from that.
Okay. I guess one final question just came in. Did you consider using 40 mil aggregate instead of 20 mil due to the thickness of the concrete?
No, we didn't. We only ever use granular A as a base. So that's what we used, and that was, again, with input from sort of all our resources. There was some discussion about maybe putting in a thicker concrete because I think 200 millimeters was pretty much the minimum thickness we could use, and with having dowels and tie bars in there, and we wanted the dowels for the load transfer because I think in Golder's pavement design, we could have gone with a thinner concrete, but without dowels. And because of the trucks and everything, we wanted to have dowels, so we ended up increasing the concrete to 200. And then the contractor actually asked if they could make it a bit thicker because they were worried about cover when they saw cut. They didn't want to saw cut into the dowels, but we ended up sticking with 200 mils, and that was it. But no, the granular was just granular A.
Okay. So thank you very much, Ben. That's all the questions we have. But we really appreciate your overview. I'm sure some of the participants on the line from other municipalities will have a lot to think about when it comes to their maintenance program, and hopefully, they'll reach out to you or us about, potentially having their own pilot project in their municipality. So thank you, Tim, and thank you, Ben, again.
Yeah, if anyone listening has any questions or anything, feel free to reach out to me and I can provide you whatever input you need. But thank you very much, Alan, for having me, and I appreciate it, and I enjoy talking about this.
Thank you. We appreciate having you. In terms of the next webinar, we're going to keep our case studies going. So Ben did a phenomenal job providing an overview of his project. August 12th, we have another case study. We're going to be looking at the Jamestown Avenue Overlay Project, which is an unbonded concrete overlay in Hamilton. We have Michael Beck, who will be providing an update. Hamilton has slowly emerged as the concrete champion in Ontario, besides Windsor, and they've done numerous projects over the last few years, but the one we're going to focus on is the unbonded concrete overlay in Hamilton. Here's just a sneak peek of what it looks like. So it was asphalt, severely there's lots of deficiencies, severely rutted. And what we ended up doing was we milled it off to the concrete base. We had a separation layer, and we poured 100 mil concrete pavement right on top. So it's very minimal removal of granulars or even compaction, which really impacted how much this project cost. And Hamilton was able to save a lot of money by doing this overlay. So hopefully everybody can join us in August, and hopefully you enjoyed today's presentation. Thank you very much for participating, and we look forward to your participation on August 12th. Have a great day.